We started this whole fiasco by going from 1D, or 2D maybe if you want to include both position and time, to 3D. But we didn't just go to 3D. The position derivative in the 1D case had to turn into a Laplacian. But because a lot of potentials in the real world, including the one that we studied last time, are spherical, which means they're only dependent on radius, that means that as opposed to Cartesian coordinates, it's a lot easier to deal with them in spherical coordinates. Unfortunately, that also means that we have to deal with the spherical Laplacian, which is what led us to our current place. So, last time we talked about the asymptotics of a potential solution to the radial equation. It's going to look like a polynomial of the form rho, and remember rho is equal to r multiplied by the square root of minus 2 me over h bar. So it's going to look like rho to L plus 1, where L is from the separation constant. And as r, or rho, approaches infinity, it's going to look a little bit more like e to the minus rho. So what's in the middle? Well, we tried to figure that out by stripping this function of all, well, no, we're not stripping it of all of anything. We stripped it of its end behavior by multiplying it by e to the rho, and we strip it of its beginning behavior by multiplying it by p to the minus l minus 1. So around the beginning and the end, it should be approximately 1. So what does the middle behavior look like when we isolate it? That's what we need to talk about today. So back then, we wanted to transform psi r into psi r hat, which is equal to psi r with both of the ends taken off. Oh, that's not rho. But then, once we do that, is this going to be easier to work with or harder? So first, let me recall Schrodinger's radial equation, which is d squared psi r over dr squared, which I'll just write is psi r double prime, is equal to 1 minus rho naught over rho plus L times L plus 1 over rho squared, the ungodly centripetal term, multiplied by psi r. So this is what we're dealing with, unfortunately. So now we pray that with overline, things are going to be simpler. So are they simpler? Oh my god. That thing right now. Sorry, but are they simpler? Well, what happens when we take the first derivative? We get, this is going to be by the product rule, psi r prime rho minus L minus 1 e to the minus p, rho plus psi r multiplied by the derivative of this, and we once again have to apply the product rule, which is going to give us, actually let's not restrict it using parentheses, there's the undo button, so this is going to be minus,
okay, I'm gonna kill this one. What is it?
Minus e to the minus rho, that's over there.
No supplies. Okay.
How are they getting in? The window is closed.
I think I killed it.
Okay, so minus e to the minus rho to the minus L minus 1, plus what's the other term? Well, that's actually also going to be a minus, since we're using the power rule on this one. So you take this out, this becomes minus L minus 1, this becomes rho to the minus L minus 2, and this is e to the minus rho. things are already looking very, very bad. So now, what happens when we take the second derivative? Well, perhaps, actually, we should do things the other way around, because we want to plug this into psi r double prime. So we're going to let psi r be equal to psi r over line e to the rho to the L plus 1. So what happens when we do, this would be minus, sorry. So what happens when we do this? Well, we get psi r prime prime is going to be equal to, no, since we're applying the product rule, we have to do this one derivative at a time. Psi r over line single prime e to the minus rho to the L plus 1 plus psi r over line multiplied by, via the product rule, minus e to the minus rho to the L plus 1 plus e to the minus rho L plus 1 to the L. Okay, things are looking fine so far. And now we take, well, first let's factorize it. We can rewrite this as e to the minus rho to the L multiplied by, or even rho to the L plus 1 multiplied by psi r over line prime. This gets factored out, plus,
Can you go to the blackboard?
okay, let me finish this. Psi r over line multiplied by, what's on the insides now? This is just minus 1. And what's this? Well, it's now just going to be L plus 1 over rho. Okay, so things are already simplifying a little bit. Let's move to the blackboard. So psi r prime is now equal to e to the minus rho to the L plus 1 multiplied by psi r prime over line plus psi r over line multiplied by L plus 1 minus rho over rho. Okay, so now what happens when we take the derivative again? This is probably bad for me. I'm going to put a minus 1. What happens when we take the derivative again? We get psi r double prime is now equal to, as you can predict, things are going to get even worse. First, you use the product rule and take the derivative of what's inside here, which gives us e to the minus e to the minus rho to the L plus 1 plus L plus 1 to the L e to the minus rho. So that's the first term. Multiply that by this. If you can't tell, this is going to end up a little bit bulky at the end. Then the second term is taking the derivative of what's inside. Here we have to use the product rule again. So you take this, then you use the product rule to take psi r over line multiplied by minus L plus 1 over rho squared. And then, now that we've taken the derivative of this, we can close this off and multiply it by e to the minus rho to the L plus 1. So as you can see, things are messy, but we can factor them to fix them. So we once again factor out e to the minus rho to the L plus 1 multiplied by, what's this, minus 1 plus L plus 1 over rho, and then you get into the meaty details, and you're going to get, well, this is still the exact same. Minus 1. And so, what's over here? Well, you get, should that end? Yeah. Okay, so the outer parenthesis is still going. So plus, that's just going to be psi r double prime plus psi r single prime L plus 1 over rho minus 1 plus psi r over line times minus L plus 1 over rho squared. And there we go. That's all of it. So now we're already probably begging for mercy. But we have to plug that back in to this equation. And what do we get as a result? Well, we get, what space will I have? Okay. E to the minus rho, I'm sorry, I know I'm blocking, but I can't do much about it. Rho to the L plus 1 times minus 1. Can I factorize this even more? Not economically, no. Yeah, no. Minus 1 L plus 1 over rho minus 1 times psi r over line prime plus psi r over line L plus 1 over rho minus 1 plus psi r over line double prime plus psi r over line single prime L plus 1 over rho minus 1, which thankfully is going to collide with this to provide, okay, let's erase this, L plus 1 over rho without the minus 1. So we're going to have this. And then plus this double prime. So this is already taken. Wait a minute. Oh boy. Actually, it's much worse than what I thought. So let's see what happens when we distribute this out before we put this into the equation. E to the minus rho to the L plus 1 times this goes first. Then all the additional terms come second. So you're going to get, first off, 2 psi r over line prime L plus 1 over rho to the minus 1. Then you're going to get psi over line minus L plus 1 over rho squared plus that. So minus L plus 1 over rho squared plus L plus 1 over rho minus 1 squared, which is going to make things even worse if you can't tell. So here it is. That's the full package, and that is equal to what on the other end? Oh, that's equal to 1 minus, that's just a constant, over rho, plus L times L plus 1 over rho squared multiplied by psi r, which is psi r over line multiplied by, where was it again? E to the minus rho to the L plus 1. So at the beginning, we get to shave off at least a few terms. Like we can shave this off of this and that off of that. But that doesn't make things happier. It makes things slightly less bad, but they are still absolutely terrible, if you can't tell. So what do we do to get around this? Well, first things first, we unify the psi r over line terms. So, erasing everything that's currently above me, we get psi r double prime plus 2 psi r over line single prime L plus 1 over rho minus 1 plus psi r hat. That is going to be a challenge to work with. First, we expand this. This is going to give us L plus 1 minus rho squared divided by rho squared minus L plus 1. And actually, no, that's going to be minus L minus 1. So as you can see, things are not looking tidy in the slightest. First, we expand this, which is going to give us L squared plus rho squared plus 1 plus 2L minus 2 rho minus 2 rho L minus L minus 1, which means this disappears and gets absorbed into this, and these two disappear, and we're eventually left with L squared plus rho squared minus 2 rho L minus 2 rho plus L divided by rho squared. Okay, as you can see, things are slowly starting to lose control. But we can thankfully condense this into rho plus L squared. Sorry, rho minus L squared. Not that we can do much else at the current moment. Now, we have to suddenly deal with that colliding with this. So, to say the least, things are going to get messy. So we get rho squared. Okay, let's see, how do we go about this? We get rho squared minus 2 rho L plus L squared minus 2 rho plus L over rho squared minus this guy coming in from the left, which is going to be over rho squared minus rho naught rho plus L times L plus 1, or plus L squared plus L, which means that a lot of things are actually going to be a pleasant surprise and cancel out. Like these two are going to cancel out, and these two are going to cancel out, which leaves rho naught rho minus 2 rho L over rho squared. We eliminate this and remove these, and we get rho naught minus 2L over rho. This is a very important number that we'll talk about later. So now the equation is actually suddenly looking simpler. We have rho psi r over line double prime plus 2 psi r over line single prime L plus 1 over rho minus 1 plus rho naught minus 2L over rho psi r over line is equal to 0. Wow, that's actually pretty nice. We didn't even have to use 2 lines to write it down. Sorry, that came out wrong. So, now what else can we do? Now it is time to get even messier because we are going to work with power series. There's absolutely no way to proceed other than this, trust me. So let's see. What I'm going to do is multiply both sides by rho first, which is going to make things look slightly cleaner before the apocalypse arrives. So that's a constant now. Now, we assume that, and I'm going to transfer boards for a second here. We assume that psi r over line is equal to, for some summation, I equals 0 to infinity, ai r to the I. So now what happens when we do so? It's actually going to be rho to the I in this instance. What happens when we do so? Well, this is going to give us what? Psi r prime is going to be I ai rho I minus 1, and psi r double prime is going to be I minus 1 ai rho I minus 2. Now it is time for the apocalypse. We plug everything in and we get rho. Oh god. Oh god, please save me. I equals 0 to infinity of I times I minus 1 ai rho I minus 1 plus 2 sum from I equals 0 to infinity. I'm just copying straight from there if you didn't notice. L plus 1 minus rho times, where was it? I rho I minus 1 plus the sum of, well, we can actually take rho naught minus 2L outside. The sum from I equals 0 to infinity of ai rho to the I has to be equal to 0. So simplifying things a little bit by removing all the sigmas and uniting them under one sigma. That sounds so wrong. You get I times I minus 1 ai plus 2 times L plus 1 minus rho I ai. Yes, that looks horrific. Do not question it. Actually, I'll free a few of them. ai rho to the I minus 1 plus rho naught minus 2L ai rho to the I has to be equal to 0. And now we do power series analysis. Do we keep going?
Oh, in the morning?
Let's keep going for now. So, how do you even deal with power series like this? Well, eventually you realize that you kind of have to break it up into two separate power series. So, this, when I is equal to 0, actually, I think this should start from 1. Oh, no, this gets canceled out anyway. So this is going to start from 0. So when I is equal to 0, well, this term is going to not exist. And this term is going to be rho naught minus 2L multiplied by a naught. Just going to be a constant. Now when I is equal to 1, this is going to give us, well, this is still going to disappear. And you get 2 times L plus 1 minus rho a, should it be I or I minus 1? A 1 rho to the 0, sorry, a 1, okay. So these two are both degree 0 terms, and so they have to cancel one another out. Hence, 2 to the L plus 1 minus rho a1 has to be equal to rho naught minus 2L a0. Or in other words, a1 over a naught has to be equal to, and remember, they have to cancel each other out because the right side is 0. So a1 over a naught is equal to rho naught minus 2L over 2 times L plus 1 minus rho. So now what's next? Well, we try to establish a connection for some arbitrary number of terms. So what's a k plus 1 over a to the...
You should drink water.
Okay. Okay, so now, what's term a to the k going to look like? Well, this is going to give us the degree k term, and this is going to give us the degree k term at I is equal to k plus 1. So realize that the k degree terms, rho naught minus 2L times a k rho k, that has to cancel out with what this is when I is equal to k plus 1, i.e. k times k plus 1 plus 2 times L plus 1 minus rho k plus 1. Yeah. A to the k plus 1 p to the k. So that means this has to be equal to 0, and hence a to the k plus 1 over a to the k has to be equal to, you move this to the other side, so these two are now equal to one another. So a to the k plus 1 over a to the k is now equal to rho naught minus 2L over k times k plus 1 plus 2 L plus 1 minus rho k plus 1. And so now, wow, I do not have the energy to keep going. Yeah, so basically, just to follow up on our promise, this k plus 1 factor gets separated into the outside, right? And then you realize, because of this relation, that means that ak is equal to so and so and so on. This numerator never changes, so ak plus 1 is just going to be rho naught minus 2L to the k plus 1. This denominator is often going to change, so you're going to get k plus 1 factorial. And here it's actually going to be a falling factorial, so I don't have the energy to put into this anymore. Okay, look, we'll continue this next time. Thanks everyone for watching. We'll see you in the next one.